Welcome everyone. Today I will be testing Blazor Web Assembly with C#. I also used Azure DevOps to keep track of everything that I wanted to achieve. Azure DevOps with the pipelines and YAML also allow you to do automated testing. I also covered how to achieve that. I also used Docker Desktop due to the absence of a valid subscription that otherwise would allow me to also put that in the pipeline. I also always cover the potential or incoming changes that might come in the future. In this case is .NET 8. That one of the changes, for example, is the quick read. And for that reason, for this specific tutorial, I did not cover in big depth the list. In order to start, you will need Visual Studio Community 2022 or higher. Make sure you have ASP.NET and web development. That will most likely include most of the things that you will need. So you start by creating a new project, a WebAssembly app. I did not manage to get the Docker to work at first try. This is the first attempt. I used .NET 7 to create the first application and all other applications. The reason why I failed the other ones were due to Docker and the built-in support for creating the images. Unfortunately, Blazor is still not included in the built-in container support. But we did a Dockerfile in order to circumvent that issue. Also, if you are working in a team, this is one of the very first steps that you have to do. But even if you are an individual developer, I always advise you to do it. The next thing that I tried was to immediately use built-in container support in order to see if it is working or not without modifying any of the code. Unfortunately, it does not work, so you might have to wait until .NET 8. They are still working on it. We will see if it is included or not. I have kept this trial in case someone else also tried it and managed to make it work. Feel free to leave it down below in the comments, because I'm a big fan of built-in container support because it saves a lot of time. And I'm just testing. The writing of a Dockerfile can consume unnecessary time, so I'd rather not have to do it. I then passed to the Dockerfile using the standalone with Docker, which is also included in their documentation. When I first deployed, there was some kind of issue. This was the second try. For some reason the menu disappeared and it did not work. This is the difference between debugging and the first publish with the Docker container. This is why I always do this type of tests in the beginning, because if I have continued and done this only at the end, I would never notice that where the problem was coming from. I would probably assume that there is some kind of code error or something like that, but I decided to make a third attempt, created another project in another repository, and restarted everything. This third attempt, the debugging and Docker image worked as intended. Please remember that the Docker is as if you just published or deployed your application. Fortunately, I don't have a subscription in order to make it part of the pipeline, but it is always a good practice to deploy. You can at least show everything working to whomever asks for the current state of your project. So again, I create the nginx-conf and a Dockerfile. After that, you run the usual commands to create an image and to deploy the image in the container. It may take some time to create the Docker image, depending on your machine. After it finishes and the container is running, notice that you can click the link in order to open, in case you were not the one that configured the port. Make sure that you press F5 or Alt F5 or Shift F5 depending on your browser in order to properly refresh the entire page. Notice that the menu is now working, so this first step was to make sure that the debugging corresponded to the published application. So this is actually quite important. Always make sure that what you're running in your machine will technically work on in this case it is a Docker container or a Docker image, and those two always match. This way you have everything configured from the get-go, and every time you make another change and you publish, you can always compare the two of them. This will help the usual confusion of it's working on my machine, why is not working on yours? Because the container is somewhat an isolated environment, and that should work in most machines. My configuration is, even if I am running on a Windows operating system, I do have a Windows subsystem Linux, and Docker is also using Linux. So I am developing in Windows, but also testing for Linux. You have to configure that in Docker Desktop. The new Windows subsystem Linux, if I'm not mistaken, is version 2. It is no longer an emulation of the operating system. Linux is actually installed inside the Windows and running in parallel with Windows. So it's not an emulation anymore. So it's good to have. It is fairly simple to configure and install. And this is also very good for testing. So now we can start messing around, make some usual monkey tests. Just to get acquainted with the project, the platform, the type of code, the syntax, and so on and so forth. So in this section, I passed some of the code behind and started to do unit testing and created a new MST project. This is one option that you can do. You can pass the C# code to code behind and leave only the HTML and CSS in the front. I immediately tested everything again with the container and the debugging, just to check if it breaks something or not. One of the things that I also do in the beginning is immediately create a new project. I often use Microsoft Test framework, especially with C#. I made sure to create the project with the same framework, .NET 7, in order to not have some kind of conflict between Blazor and the Microsoft project and the Microsoft Test project. In Visual Studio you always have Test Explorer, and you can also do automated testing with the Test Explorer. And when using Azure DevOps with YAML, you can also reuse the exact same test methods and run them in the Azure DevOps using a YAML file. But for now, we need to first make sure that everything runs, the project is valid, the tests are also working and are accepted in Visual Studio. So in this case, we are just doing manual tests in order to see the Test Explorer is recognizing or not. Make sure that you reference the project in question. In this case, the Microsoft unit test project needs to reference the Blazor project. Otherwise, it will not be able to find that file. I do advise you to never do the opposite. Do not reference Blazor, for example, or the front end to reference a unit test project. Those test projects are meant to just test. They are not meant to have some kind of code written in there in order for you to reuse in some other project. Regarding naming conventions, depending on if you are an individual developer or belong to a team, I advise you to always ask your team if they have some kind of convention, naming convention for projects, even the unit tests. After that, I wanted to test a .NET library, not a framework, a .NET or a .NET standard. Again, in order to match the Microsoft test and the Blazor, which are both .NET 7. Instead of using code behind, I wanted to make sure that it was also possible to make a simple library and reuse that code in one page or multiple pages. Which, by the way, I'm calling them pages, but they are actually Razor components. So they are slightly different from the ASP.NET HTML pages. So when you see those pages inside the project, they are actually Razor components. In this example, I'm going to continue to reuse the existing code because I'm, again, just testing the boundaries and what I can do or not inside the Blazor project. So I'm going to pass the code that is inside the counter page or the counter component. I'm going to extract it to the library. And I'm going to immediately test that code from the library. Depending on your team and the time that you have, you may or may not want to do test-driven development, as in you make the tests first and then you write the code, or you do the code first and then you make the tests, or you do some kind of hybrid and you do the two at the same time. In an ideal world, you should do tests first and make all the mistakes in a project that it will never affect your deployment. In order to access the library, you need to use the using my library. In order to recognize, make sure that you reference the project. In this case, there is no issue with the front-end project to access a library, so you can add a reference to the my library. If there is some kind of error, in the first moments that you are creating your projects and there's errors everywhere, try to unload all of your projects and reload them again. Then reveal. For some reason, when you first try to create a project, they kind of get stuck. There's probably some kind of cache that is not cleaning properly. So just unload all projects, reload them again. That tends to fix the issue. So I pass the code to the library. I now have the unit test project. I made the necessary project references. And then we can now make a unit test. Now notice that the Razor component immediately recognizes the code written in C#, even if it is in a different file in a different project. So this will allow for reusability. And some people don't even consider these kind of things, but you never know if one day you're gonna have to move your entire project into a different UI. And if you have most, or at least a considerable amount of code outside of the Razor component, it will be easier to migrate to a different project or a different framework. So it's always a good policy to, if possible, keep the code isolated and maintained in another library, so to speak. If that is not possible, do code behind, keep things a little bit cleaner. If your team does not want that and wants to keep everything in the Razor page or the Razor component, well, it's a team decision. My personal take is you should always keep them isolated so they are reusable. So again, no issues here. And it is clearly possible to have a Razor page or a Razor component and have a library outside and at the same time test that code that is in a completely different space. Debugging is also extremely important. In this case, the unit test did not crash, but if you have some kind of issue, or for example, you are debugging and you didn't write a unit test and it's crashing, and it appears reload Blazor website or Blazor app, it's probably because your modification has some kind of issue, some kind of error. It's always a good practice to move that code into a unit test and try to debug the problem, troubleshoot it in the unit test and not in the WebAssembly project or app. I was reviewing some of the things that I could test. I noticed that Quick Read is probably coming .NET 8, so I skipped it. I'm going to wait for the release or a stable release of it. So since I now have a few unit tests written, I like to immediately write a YAML file in order to do automated testing every time I publish my code to the repository. This will help me find things that sometimes I don't catch with manual testing, because automated testing sometimes needs some tweaking, and we actually find some of those issues, specifically for example, when you create auto increment IDs and you manual test something, the auto incremented ID, it always starts at 0, but in automated testing, again, this is just an example, it will not start from 0, it will accumulate all the tests. I am triggering just in master. If you want, you can have it triggered only in your branch instead of the master. The pool is in Ubuntu and my debugging is on Windows. This is the kind of things that you can try to do. You can even make different pipelines or different YAML files in order to test in different operating systems. I'm using .NET 7. I make sure I use only .NET 7. I then restore, build, and lastly I run the tests. I made sure that is only running the MST001 Microsoft tests, or the project that contains the tests. The above line runs all tests independently of their naming, and the second line that is currently uncommented will run only the tests by name. So in this case it's only fetch data 001 and the UT counter 002. Depending again in what you want to do, you can either run all tests or just a few of them. In my case, I'm going to run all tests. And all tests that I'm going to place inside that project is going to run every time that I push to the master branch. Notice that you have a summary, and then there is also something that is called tests right in the next, and it will tell you all the details that those tests have. You can either press clear or select all of them in order to check. So it matches the manual test that you've written, and the automated testing is also reusing those manual tests. This is important not only for teams but for individual developers that have a very short period of time and they can't afford to make different types of tests. So I created a new objective and I decided to create a new Blazor Razor page from scratch and test the EditForm inputs. This will have a new entity, the new page, everything from scratch. Again, I'm going to isolate the code into the library. I'm not going to use the code behind or the C# code inside the Razor page or the Razor component. I called the detail form, 01. You can name it whatever you want if you are following this tutorial or this review in order to learn Blazor. After that, I create an entity. This entity, because of conventions, I usually give my entity's name the exact same name as the Razor component or the Razor page. This is due to my experience with ASP.NET MVC and the scaffolding process, which can also be applied in desktop apps. So for convention, I always give them the same names. I also do advise you to do it because I did not find any kind of documentation regarding that. But in the future, it might be possible to use scaffolding too in Blazor. So you just create an entity, you scaffold it, and it will create a code first database and a Razor component web page. So these kind of things, because we are inside the Microsoft environment, they are sometimes a good practice to follow. But if you use different names, there's not really an issue there. You just might not leverage certain things that might or might not appear in the future. In my experience, you can probably expect something like that to happen. Since I was testing with Lua, inheritance and composition, I also wanted to test inheritance. I wanted to make sure that nothing broke just because we're using Blazor. Not that it would be likely, but anyway. Inheritance in C# is much more simpler. You just make a semicolon and you call the entity in. In order to add the option to the menu or the nav menu, just copy paste the division and you modify to the same name of the page. Make sure you use the name that is inside the page and not the name of the file, because they can be different too. Then add another project, an interface project with files that are mostly interfaces and enums in order to keep or maintain good solid principles like the list-of, the interface aggregation, the dependency inversion. If you are always unsure if you're gonna need it or not, just do them anyway. More often than not, in the future, they might come in handy. So in my experience, I rather always do them than not. As a side note, if you want to inherit from two different files, just put a comma and it will inherit, and it will automatically inherit from both of them. In that case, is inheriting from the parent and inheriting from the interface that will then be exposed to a factory that I will create after. Make sure the project references are properly done. Again, depending on what you want to do, you can or not pass everything through the interface and never directly to a library. But I then made some code reviews and decided to remove the using my library. Notice that is now commented. So now the Blazor projects or the Y interfaces are forced to go through the interface and never directly to the my library or to the C# code. When you're testing, you can do whatever you want. You can test the raw libraries or the interface. But in the Y projects or the front-end projects, I advise you to always use an interface. Even if you don't think you're gonna need it, it's a good practice to do. To keep your code well organized and will follow the solid principles, which are probably the ones that most developers and engineers follow. Then I made another project to follow creational design patterns. In this case, I'm only going to do a factory and builders. You can also do singleton. You can also do abstract factories or even singleton. But in this example, factory is more than enough. We're just going to create the detail form or the entity that we are using in this new Blazor page. In this case, we never create the instance directly, the detail form. We instead use a factory to create them. Factory is usually only a factory when you have more than one type of creation, of creational designs. But even if you only have one, even when you're developing, you think you're only gonna need one, it's a good practice to create a factory anyway. And obviously, if possible, use an interface. Even if you have to expose the raw code from the factory, because you need to, in order to create the interface, you need to make a new raw factory, so to speak. Do it anyway. Do the interface anyway. So in this case, at this point, we are referencing the raw factory and the interface only, but the my library but the raw code from the my library is not exposed. After that, while you write the factory code and the interfaces, feel free to do unit tests again. You won't need to edit the YAML file if you made the file to run all tests inside that project. So every time you make a new manual test and you commit to your repository, it will automatically run all tests that you write. This will allow you to always have continuous integration and continuous deployment or development, depending on what the terms that you like to use inside your team. This case is just development because the pipeline is not deploying and we are manually deploying. Our current detail form has this format. We're not trying annotations. Notice that is required. We'll give an error message if it is not filled or the length exceeds that. We then use the status and the input class. On initialize is going to call a method, and that method is going to create an instance of it using the factory. Again, if possible, avoid creating instances directly from the library. Always use an interface and a factory. Ideally, before even debugging or creating your image, run the tests first. Once they pass, you try to debug and see if everything is working or not. The age is calculated automatically behind, you're not inputting it. Then added an int. I then added an int or an integer. I also made a simple test in order to check it. That integer was to just make a simple test of an adapter. So it is common that in the entity you save an integer, but in the front end you present a text or the option of the dropdown. So I created an enum. In this case, it is inside the interface project, and you make sure that you assign a specific number to that text. This way, it will allow you to communicate between two different expectations, so to speak. One is in text, and the other is an integer. The dropdown will then be somewhat dynamic. If I add another option in the subscription enum, it will automatically update the Y, and so you don't have to manually input those values. He also uses the value is actually an integer, so when you save, you are saving an integer, but the input in the Y is a text. Next in my objectives was a list. Again, I'm not going to make a quick read because that would imply me to install .NET 8. So I just reused the code that I had in their list and applied it in this page. I use the factory in order to create random values and populate a list. If this was in production, obviously you wouldn't be randomizing data. But for these purposes, I just randomize integers, data types, and text, and just populated a list with it. But this was also a good experiment in order to showcase the factory. So you pass a simple option, and given the option, it will either create a new details form, which is empty and then populated, or it immediately populates with something, with parameters, for example. In this case, I'm just deliberately inputting random generated values. In the Razor component page, I changed the on button in order to do two things instead of just one. So I aggregated these two functions into one, and it creates the model and the list. Or better, it creates a new model and populates the list with RNG values. I converted the on and initialize in order to make sure that it always filled that value. In terms of changes, I did add another status. The paragraph, you make sure that the role is in status in order for it to keep track. For it to keep track of it. The Blazor will automatically take care of that design. The list is then dynamically populated. In this case, it is a simple HTML table. Take notice that .NET 8 is probably going to bring a new grid view, or instead use a Syncfusion, Telerik, DevExpress, for example. Their products are much better than probably any one individual can make. So if you can get your hands on a subscription like that inside your team, I advise you to use those type of components. And that is also why I didn't take a lot of time with the list or the table. You can also pass that table into a Razor component if you want to, and try to pass input parameters in order to make that component reusable, which is also a good practice long term. That way, if something new comes in, you will be able to quickly shift between your component and a new component that's coming in. This method will simply resize the array, the current array of the list. I could have used a list or an hash set, but just to make sure that could make another test with a simple array and how to resize that array and append a new model into the list. I also made a verification. So if you want to continuously add new models to the list, don't call this check if already exists. If you want to only add one and modify only that one, keep this check if already exists in place. So I wanted to spend less than a week's work on reviewing Blazor. I'll probably make some further changes regarding options some other time. But in the future, I will probably try to create an options page and try to control the customize all of the layout in that page. In Windows Forms, it is possible. In Blazor, I will still have to figure out how to do it. So in this case, I'm just creating the page just to make sure that in the future this is what I want to pursue. These are the next objectives that I want to pursue. So I keep it as a blank page in the project and also make those comments inside the Azure DevOps. Also add it to the new nav menu in order to not be forgotten in case I restart this project. Lastly, I publish the project again as an ISO image, or a daemon image, or a container image, or a Docker image, whatever you want to call it. Since Docker is the continuation of daemon tools, or the virtual CD, in case you used it when you were younger, the technology is basically the same. Docker Desktop has the tendency to leave those unused dangling images. You can delete them, especially if all your images that you create have a specific name. So make sure to always give them recognizable names. So last, to test everything, you can check that it is working both in debug and the manual deploy of the image. Again, debugging is in Windows, deployment is in Linux. So these were the objectives that I wanted to cover in more or less 1 week's work. I tend to track all of my objectives and references that I use and what I accomplish or not with Azure DevOps, because it also allows me to create YAML files to automate the tests while I develop and every time I push to the repository and test both in multiple operating systems. Again, the tests. If you do this process from the very beginning, every time you push in automated tests, you might catch some kind of error, or you modified some part of your code and you forgot to manually test it, and it will complain, so to speak, and say, hey, you made an error here. But at least make sure that you have a good test coverage and that tests are meaningful, because 100% test coverage means nothing if the tests are not actually testing anything. So the percentage is not the important thing, is the quality of the test. The major difference was when I stopped coding from one day to another, and I commit. In the next day, there's always some minor thing that I forgotten or I didn't finish or I get distracted. So the automated testing always caught up, and it's like a 5 minutes hotfix because of typos, and I'm back on track. The other thing that he actually caught was specifically the ID. I had to add an additional method to reset to 0. This is because in manual testing and automated testing there is a big difference. So in this type of things, either you do not test it, or you need to make this type of methods in order to make sure that everything will pass, so to speak. Or you need to rewrite your code or make further code reviews in order to properly test this kind of things. So again, manual testing is important, automated testing is also important, but the combination of both is what makes the difference. In terms of references, I'm going to leave them down below in the description. Feel free to add comments below if you find some additional. Some of them might not work currently with .NET 7, but with .NET 8 it's going to bring some changes. Also, don't forget to check the .NET YouTube channel. So regarding more or less 1 week's work on Blazor from scratch, this video is a little bit longer. It has some boring parts on it, but I wanted to make a different kind of video this time. So that's it for today. I will see you in the next video.